అనుకున్న మీ అందరికీ కూడా ఆల్రెడీ షెడ్యూల్ పంపించడం జరిగింది. దానిలో పార్ట్గా 4:30 నుంచి 5 దాకా ఇస్రో సైంటిస్ట్స్ మనకి ఈ ప్రోగ్రామ్ని పిల్లలతో ఇంటరాక్షన్ అనేటువంటిది ఉంటుంది. అయితే ఈ మొత్తం ప్రోగ్రామ్కి సభాధ్యక్షత వహించవలసిందిగా మూర్తి గారు, బిఎస్ఎన్ మూర్తి గారిని కోరటం జరుగుతుంది. సార్ గురుగారు, బిఎస్ఎన్ మూర్తి గారు. బిఎస్ఎన్ మూర్తి గారు స్మార్ట్ కెనడీ స్కూల్ చైర్మన్, అలాగే రామకృష్ణ మఠంలో పేరెంట్ కౌన్సిలింగ్ కానీ, అలాగే స్టూడెంట్ సైకాలజీ మీద కానీ, వీటన్నిటి మీద కూడా గెస్ట్ క్లాసులు తీసుకునేటువంటి గొప్ప వక్త. అలాగే బియాండ్ దట్ ఏ నైస్ హ్యూమన్ బీయింగ్. మాకు కొండంత అండగా ఉంటూ ఈ యొక్క ప్రోగ్రామ్కి అధ్యక్షత వహించి ఈ ప్రోగ్రామ్ని నిర్వహించవలసిందిగా మూర్తి గారిని కోరుతూ, సార్ మూర్తి గారు ప్లీజ్ సార్. థ్యాంక్ యూ.
నమస్తే అండ్ థ్యాంక్ యూ ఫణి పవన్ గారు. ప్రోగ్రామ్ షీట్లో ప్రోగ్రామ్ చైర్మన్ అని పెట్టారు. నాకు ఐఎమ్ ప్రివిలేజ్ టు హ్యావ్ దిస్ డెసిగ్నేషన్ టుడే ఫర్ దిస్ వెరీ వండర్ఫుల్ ప్రోగ్రామ్ బికాస్ వీ హ్యావ్ ఆల్మోస్ట్ 1000 స్టూడెంట్స్ వెయిటింగ్ టు రిసీవ్ అవార్డ్స్. Now, as per schedule, we are starting 4:30 exactly. I think we are 2 or 3 minutes late, but let us start off as fast as possible and end it as fast as possible because children have to go back to their homes as fast as possible. Okay. Now, the first program as per schedule is 4:30 to 5 p.m. It is given interaction with ISRO scientists. May I now request Shri D.L. Ravi Kumar.Group, Group Director, Mission Simulation Group, U.R. Rao Satellite Center, ISRO, Bangalore, to please come on to the dais. Also, Shri M. Harinath Garu, Group Director, Program Management and Systems Group, IRS and SSS Program Office, U.R. Rao Satellite Center, ISRO, Bangalore. Please occupy the dais. Without wasting much time, I call upon the students and then mics. Please arrange the mic runner, please.
It is a great pleasure to stand in front of the student, teachers, community, as well as a lot of people behind this eAbhyas Academy activities. It is in fact a great pleasure for me whenever I get an opportunity to interact with students at various forums, be it when students visit our own U.R. Rao Satellite Center at Bangalore, on occasions like National Science Day in the month of February, the 28th of February. You all know that we celebrate National Science Day. And apart from that, in the month of October, we celebrate World Space Week to celebrate how the space technology is helping the lives of people all around the world. And also there are other occasions like after Chandrayaan 3 successful landing, another day is announced, 23rd August, you all know. So apart from that, whenever we get chance like this, when organizers of eAbhyas, similar offers when it comes, in spite of our busy schedules, we always prefer that we need to interact with you youngsters and then motivate you to take up careers, not only just in space technology, in whatever technologies that are going to be driving forces for improving the life of the Indians. So as part of that, myself and Dr. Ravi Kumar, we are here. Students can go ahead with whatever doubts you have. In the limited time available, we'll try to address your doubts and queries. Thank you.
Thank you, sir. Okay. We'll go on with the questions. I will announce the names of the students. We have very brilliant set of students here, sir, because they're all state rankers in this eAbhyas Olympiads. Right? Okay, first is M. Sahasra, 8th class, Little Flower School, Navipet. If you are there, please put your hand up so that the mic runner will come to you.
Hi, sir. This is Sahasra from 8th standard studying in Little Flower High School. My question is, how the success of Gaganyaan mission impacts the position of India in the global space community?
Thank you. Very good question, actually. Like this, actually, that Gaganyaan is a project where we are taking up to the for currently what we are doing is earlier we are doing that IRS and INSAT kind of satellites, but now we are going to the next level, actually. That is the Gaganyaan project. In that Gaganyaan project, objective is that actually we want to be second to the none, actually. That is what the objective. See, now like similar to the ISS, International Space Station, we wanted to go build a Bharat Antariksh Station. Actually, this project already declared. That means that actually we are, our humans, that our people will be in the space, actually. That is what that actually, this will give the boost to our total space industry, as well as that all the science academy, and also that to do the experiments on the, like similar to that International Space Station, here also our Bharat Antariksh Station also going to build up. In this respect, that the first module will be deployed in that 2028, and that along with that one 2035 will be that additional modules will be there. Complete build up Bharati Antariksh Station will be built by the 2045. That means we are going to be that one space station that will be that our laboratory for the future. That will stand that India into that one of the space eminent technologies will be proven in the future.
Thank you, sir.
Thank you, sir.
The next question is from Vinay, 10th class, Geeta School, Tupran.
So what is your next mission on Mangalyaan?
Known, and then one of the moms was also my family member. See, we subsequently had the Chandrayaan 3 mission, and then Aditya L1 mission, and then next attempts towards Mangalyaan should be, we have to take like Chandrayaan, first time we had orbiter in Chandrayaan 1, and we only orbited around the moon and, at a height of some 100 kilometer, and then collected lot of data, and then we had carried lot of payloads. So subsequent mission Chandrayaan 2 itself, we wanted to make a rover and then make it land on the moon and then carry out some experiments. Subsequently, in Chandrayaan 2, whatever some small drawback which resulted in not achieving 100% success was rectified in Chandrayaan 3. And then Chandrayaan 4 also is already a declared project wherein we are going to collect samples from moon. And what we did in Chandrayaan 3 was characterize the moon surface and then whatever materials through payloads carried out. So scatterometry kind of experiments to analyze the composition, presence of water and such similar thing. Whereas in Chandrayaan 4, we are going to bring back some material from there. So whatever required for auger-like system, where you can penetrate the moon surface, carry the sample, bring it safely back to Earth. That is one mission. And similar attempt has to be made in Mangalyaan also, so which is a project in the pipeline, but not yet announced.
There will be one helicopter actually. That helicopter will hop different places and do. And also that here actually Mars environment is actually that whatever the air density is less actually. That whatever the atmospheric conditions are very benign conditions. So there actually that landing is a critical actually. Those technologies we have to demonstrate. Then a helicopter moving from the one place to other mode, and also that there actually because of the air density is very less, the movement of the helicopter will be very difficult actually. So that designs are in the process. That soon we soon going to declare that one more mission on the Mars. Actually that is a landing mission actually.
Thank you, sir.
From Lord's Olympiad School, Badangpet. Today's my query is, what qualifications are needed to you join in ISRO? May I know, sir, please?
Tejaswini, I am really impressed by your acknowledge that what all activities we carried out in ISRO are highly interdisciplinary in nature. People of various science and engineering disciplines are required to really carry out the kind of missions we envisage and then realize and then put the country on the map of the space technology. So that way, I really don't suggest that one particular branch of engineering or science as a basic requirement. So what I suggest is, one of the modes of getting into space, ISRO is, we have our own equivalent to IIT kind of structure. We have Indian Institute of Space Technology at Trivandrum. So selection criteria is similar to admission process for IITs. So you can try for admission there. We basically try in two areas. One is avionics systems, and then other thing is related to the orbital flight dynamics, such kind of thing. Also, we have started having even postgraduate programs and then research activities also in that area. So that is one mode of getting into. Another thing is, in future, you don't have to be only directly part of ISRO as an employee. As per new space policy, doors are open for private participation, academic institutions to be part of all the future endeavors, especially new developments and all. And also certain concepts which we have developed in ISRO to be duplicated, multiplied in such a way that it will be very useful for society through these organizations. So that way a lot of startups are coming up. So you can do your basic engineering or science to be a scientist or technologist. And in addition to that, some of the people with other type of qualifications, because to run a scientific organization also we need administration, accounts, a lot of secretarial support. So that way sky is the limit. You have a lot of chances, and lot of recruitment is currently happening for ISRO. Some of you who are eligible can go to isro.gov.in website and then keep looking for offer, because you are a 9th standard student. It is long way to go, but keep in touch through what are developments happening. due to new space policy, lot of opportunities are opening not just in government sector, also in private sector, and through academia also. A lot of universities, they are coming up and then making satellites as part of their degree programs itself. For example, recently on 1st January when we launched ExpoSat, along with that several small missions when we made. One engineering college from Trivandrum, it is all-women engineering college. So they made a satellite. It is basic first step towards planning a small payload and then carry out some experiments. So that will pave way for even academia also to get in a bigger way in the future. Hope that answers your question.
Sure, sir. I will try this. Thank you, sir.
I want S. Avanti, 8th class, Abhyasa International School, Jagityal to get ready. Jaisima, please go on.
So I have a small question that ISRO found water on moon. Why can't we grow plants on moon and make it convenient to human beings to live there, sir?
To make the colonization on the moon. Colonization moon means actually that whatever be that why we have, first of all I would like to tell you that why we landed on the South Pole. The basic reason of the South Pole landing is there water actually that lighting conditions will be there and there lot of water possibility is there actually. So another thing is a continuous sunlight. Because of the continuous sunlight, the long term hardwares, all the hardwares colonization is possible in that area. So now the basic things are like suppose if you able to get that water there, then from that water we can get the hydrogen as well as the oxygen. The oxygen will be used for that our colonization purpose, and the hydrogen whatever is used for that fuel as a fuel, that will be useful for that our running our that suppose space flights actually. Space flights will move on that hydrogen as a fuel. So that is actually that idea. Then over that one, now that the scientists are already experimented a lot of growth actually is a biological growth they have seen in the space station actually. Similar kind of things going to be happening to the moon atmosphere also, but only it is a matter of time. Actually it is now it is time going to, we are going into that direction only. Slowly the growth will be happen. So now that first, that's why what we are doing is that now we are studying the moon condition actually, moon atmosphere, and also how much we can grow the biologically, how much we can see that one, then how much is the plantation is possible, how much is that we have to carry out there, and these kind of experiments we have to do first before coming to that final that stage. I think that is going to be the futuristic actually. It will happen actually. It may be taking that another 20 years, but whatever your vision. Basically it is looks very good actually. Your thinking is in the positive direction. Keep it up. And also the continuously what you can do is that you can go to that actually NASA websites and ISRO websites where that there are a lot of literature is available on the moon surface and all. Then what are the possibilities are there in that moon surface. Also you can study that one actually. So now so far we have done that sun surface level experiment only carried out. Some deeper level of the experiment is going to come in the robotic missions. So with that we may establish that colonies in that one. So one of the thing is will be the growth of the plant. All those things will be carried out there in this. I hope I answered you.
Yes, sir. Thank you, sir.
Thank you, sir. 10th class of Brungi International School, Vikarabad. If she is ready, you can ask the question now.
Are still in sleeping mode. We have heard that they are still in sleeping mode. Why they are not responding, sir?
Then conduct some experiments. It is basically designed to last only one lunar day of 14 days. And the kind of technologies, processes that have gone into realization of process are very close to what we have used in other orbiting missions. Be it for communication payloads or remote sensing payloads. So that another thing is, the shadow region of moon to the sunlit area, the temperature gradient is huge. And then electronics which are realized, so electronics which are realized to work in conditions similar to what is there in the other spacecrafts. It can cater to, if it is well protected through a thermal control system, electrons basically will operate from -10 degrees to +50 degrees. So these are the things when it goes through. As such, we have done some brute force experiments on such designs, whether really there is a chance of surviving one lunar winter where it goes through that harsh, very cold exposure for a very long duration. It is like a thermal shock. Thermal shock need not be very only when it is hot. It could be even going to the other extreme. So our systems were not designed for that. In fact, we also had crossed our fingers and then hoping that there will be some outcome out of whatever experiments we have conducted. Some of the experiments will come alive and then we will be able to gather some more data. It could not be. But subsequently, there are other missions carried out by JAXA. There is a claim that it has survived one lunar winter and then subsequently some of the functions all cannot be restored back to. And our basic 100% aim, what is put for this Chandrayaan 3 mission, we have achieved completely by surviving the full 14 days of sunlit duration. And also we have demonstrated through this Chandrayaan 3 mission, which was not a basically a planned, originally planned activity. The aim is in future, especially Chandrayaan 4, we want to take off from moon surface and then come back to orbit. From there, bring the satellite back to Earth. So we have done in this direction a lot of experiments starting from the time of satellite recovery experiment SRE2. It was done in 2009. So there are technologies required for all these things being developed in stage by stage. Definitely in Chandrayaan 4 time frame, we are hoping whatever we have demonstrated at the end of the sunlit period of that lunar daytime, end of it we had done one hop-in experiment where thrusters were fired to see that really satellite gets lifted, especially that lander platform with 4 legs. No? So that has risen by a few centimeters and then landed back. So that gives a confidence that in future we can, in Chandrayaan 4, whatever demonstrated there, we will be making use of for future. So that is why it is a step-by-step process. There are a lot of goals which is going to be left for you. Next year I will be out of ISRO. After 7-8 years you will be out of ISRO, but you are the people who have to take forward all these visions with a lot of ideas which you are giving.
So I want to add one more point to this actually. To your, this actually 14 days day, 14 days night kind of things actually. During that lunar night, the temperature goes to the minus 230 degrees. That means that almost that it is like a, you can see that one, that cryo temperatures actually. Those under that temperature conditions, electronics, basically electronics will not work actually. The design is of the electronics is minus 52 plus 100 degrees only. But these excursions will be minus 232 plus 150 degrees variation of that electronics. But however, the way there is a process actually, there is called the nuclear power. Basically we have to inject the nuclear power. That is called the RTGs actually. That is our BARC, BARC. They are having that technology. In the future we are going to inject such kind of that technologies into our lunar missions so that we can, life can be improved actually, increased. That is what that point. I think that you can take over that this kind of that new technologies like RTGs, where nuclear power, and also you can give the bright future in that line actually. So you can get that even that interplanetary missions also you can use that that kind of things, so that continuous you will get the signals and also that experiments we can carry out.
So you have to further do the research and then, get whatever that minus 230 degrees centigrade is there, that we got to manage that, okay? Before Avanti goes on, this is Akshaya Sharanya from 10th class Oxford School, Kusheguda. You please get ready. Avanti, you can ask the question. Avanti from Abhyasa International School, Jagityal.
Avanti from Abhyasa International School, Jagityal. So my question is, which launcher is used for Chandrayaan 3 and what is the specialty of that?
It was used for Chandrayaan 3, and for Gaganyaan we are going to use JSLV Mark 3 with man rating. So that way we also have a lot of plans to improve the capabilities of launch vehicles to match with the kind of payloads we want to lift it to orbit to carry out experiment. That answers your question? Or are you looking for any sub-question in this?
Sir, no.
Thank you.
Right. Okay. Akshay Sharanya, Oxford School, Kusheguda. She is ready.
Good evening, sir. Myself, Akshaya of Oxford Model High School. We are very gracious for your presence, sir. My question is, now with allowing space in FDI with Indian economy, is SpaceX slated to have partnership with India? Because we are looking forward for cost-effective and reusable space rockets by using Falcon rockets.
A lot of private industry to participate, and SpaceX is helping American space technology efforts in a big way. But you must remember that we have found a lot of innovative solutions wherein we thought with available technologies what India is going to achieve in the kind of challenges we had taken up. We have shown to the world that we can do it, and a lot of that, it has happened till now, maybe within ISRO, but in future with industry open for private participation, a lot of academia also going to get involved in this, making use of the latest technologies, whatever is necessary to realize such missions is going to happen soon. We don't have to invite SpaceX here. We can even create a competitive environment where what is our requirement immediately, so that we can really achieve. SpaceX has its own goals. They are setting up a lot of constellations for providing a lot of services. So let us look forward to our own Indian academia and ISRO together evolving some technologies necessary for achieving whatever goals you are planning to set for ISRO. Thank you.
Thank you,
And
sir.
then the next is Sri Chandana from 6th class, Sadashiv High School, Boinpalli. Harshvardhan, can go on with your question.
From Lodge High School, Jilalguda. So today my question is, what are the various discoveries made at the South Pole of the Moon, sir? I am eager to hear this from you, sir, please.
Question is very good actually. That from the Chandrayaan-3 point of view, all the experiments are successful. So what we got is actually that from the Chandrayaan-3 surface, we have put that one instruments on the surface and seen that seismology. So what is the vibration levels of the surface actually. So it will be depth up to 10 centimeter level of that soil. It has seen that what kind of the, suppose you do in that earthquakes in our atmosphere, when it is coming to the moon, what kind of the vibrations it will create on the surface, those things are recorded actually. Then coming to the minerals, actually that there is a different kind of the X-ray payloads actually. That is there are having that high energy X-rays that is pumped to the soil, and in situ experiments has carried out, and also found that what are the composition of metals, what are the minerals available on the surface of the moon. Some extent we got that this information. Another thing is that the rover motion, basically that rover it has moved on, that Pragyan rover has moved on to the surface, and then soil characterization, basically traction control. Traction in the sense, suppose you have that, if you put that rover on the surface, to move that one, traction is required. Actually whether that should not be happening the slip. If it is happening the slip, the rover will be there only actually, it will not move further actually. So to what kind of the soil is there, the soil characterization is carried out, because that the feedback comes from that one, how that motor currents and all. From there we can characterize that how good is that one, that soil, and also that whatever we made in the ground actually in that earth conditions, and then we brought some soil and then we call as a simulant, and over that one we done the experiments, how closer to that one as we are compared. So like this actually, that if you see that one, whatever is possible actually, those kind of that experiment we have carried out. Another is that technology. See, that is actually that basic idea of that Chandrayaan-3 is a safe and soft landing. Those things we have achieved. So when you are touching this one, that ground, there is a, because of the engine, there is a lot of plumes will be coming, dust will come over that one, how to overcome that one, sensor working, and also the navigation sensors. Suppose you are taking that images from the 100 meters, any craters are there and the boulders are there, the identification of those boulders, and then and also the retargeting point, going to the retargeting, this kind of, that means we have studied that navigation, guidance, control technologies, we got the hold on that one. So that means now if when any situation comes, suppose any crater comes in the way, then how to avoid that craters and safe landing, how to achieve the safe landing, such kind of things we studied. Like this, if I keep on telling that one, actually there are the n number of technologies actually that is we have demonstrated, but there is another, in a few challenges are there. I think that you can take up that one. There is I think that in the August there is one rover challenge also is coming from the ISRO, and I think that you can participate in that one, and also that you can show your rover technologies, small experiment we can show on that. That will be useful for that all the students. I think in the future you can go with these small drone kind of applications, AI applications, and that small rovers, motors driving, traction control, this kind of things. If you take from now itself, it's a habit of doing that in the robotics, and also that it will applicable for all the either space robotics or that ground robots. That is, most of the things will be applicable. So slowly you have to inject in that will help in the future industrial applications. I request all of you have to take this kind of one project in your curriculum, and also think on that one and execute that. Simplest with the nowadays a lot of electronics kits are available in the market. Use those things and get into some knowledge over that one. That will help you people to get the inject this kind of things. This is a very good idea actually. The moment you got that what are the things experiment means, that I think that you are going through the web, and also is finding out that what is happening in the lunar surface. So that is very good indication that you people are on the right track. Thank you for all you people are having such ideas.
Thank you for this valuable information.
Okay,
sir.
School Kolhapur, get ready. Now, Siri Chandana, 6th class, Sadashiva High School.
Today my question is, how can we communicate with a person who has landed on the moon by audible or text?
Has to happen between the team on the ground and the team on the in the moon surface, wherever we have landed him. Final what is can be perceived is what you can see with your eyes and what you can hear from your ears. But currently also, you know how mobile telephones or even old version of telephones were working. We were talking, but it is getting converted into electrical signal and traveling over a cable and then reaching the other end. And in between there are repeater stations wherein many such messages which is coded is put onto some carrier, RF carrier, and then it goes to different parts wherever it is supposed to be received and then decoded and then disseminated to the destination. It is happening. Similar thing has to be established, only distances have to be handled is very high. So for this there are technologies like American TDRSS satellites, and then we have our own program of IDRSS. You can find all this information in isro.gov.in. Some of you interested can go through. It is going to be launched very shortly. We have planned 3 satellites. If you keep 120 degrees apart at 36,000 kilometer orbit. 36,000 kilometer orbit, what is the advantage? I need not tell. I think there is a time crunch. So there is a lot of advantage with that orbit. 3 such satellites put at that orbit with 120 degrees apart, we can provide communication all the time from that orbit to ground. So now we have to see how we are going to establish from there to any other planet where we are going to keep our astronauts. So this is a challenge similar to what we have done in normal telephones to mobile phones to now different technologies. We are talking 5G, 6G. Similar technologies have to be applied and then realize the mission's goals.
Thank you, sir.
Thank you, sir. Now, V. Rohit of 9th class, Mastro School, Korutla. Yashashwini, you can go on.
Pursue your career. So now you are telling you are interested in designing. So that means you are also in the same path. So you have to acquire the knowledge required, which is in the form of basic engineering degree or science. And then during that, whatever you learn, you have to add to it by getting into some startup company which is going to do some designs, or ISRO itself. That is why now it is not limited to getting job only in ISRO, and then only you can do something related to designs for space technology. So hope that answers your question. I need not elaborate further unless you have any further query on this.
No, sir. See, your interest is very good actually, that you are asking the like a design. So that means you are motivated to that make the satellite itself.
Yeah.
So that is very appreciable thing. So the first and foremost thing is that actually satellite total design, if you see, it is a multidisciplinary. It is having the electronics, it is electricals, it is having the power, batteries, then communication, and also control system, that sensor. These are the technologies are there in that same one single satellite itself, including that communication and all. So this normally we call as a bus actually. Bus means that which has to, that spacecraft has to run actually day-to-day activities like the orientation maintaining and sun pointing, earth pointing, and also the orbital rotations. Suppose it is a deviates the orbit, we have to correct the orbit. Kind of things are the basic things. Over that actually payload operation. Payload operation means what is the purpose basically. You want the communication satellite or remote sensing satellite. Based on that, another way of the design. So there is a payload design different, and also the bus systems design will be different. Basic fundamental things will be same. Basic electronics, whatever you require for the electronic systems, mechanicals, basic requirement, mechanical. So if you want to get into this kind of applications, what you required is that basic understanding of the electronic circuits. If you are in the electronics design, if you are interested in the mechanical things, you should learn that one, analogical systems for the mechanical area. So that means that actually that systems design, if you are interested, there are a lot of literature in the in the internet actually. Just you go to the spacecraft design technologies like that, then you will get a lot of information, and that now that our students now they have started from the 8th, 9th onwards, that actually small projects they are carrying out on the some simple experiments like battery technologies is there, but actually that how that battery from the solar panel, how to generate the power and how to use that power. So there is a conversions, a DC convert kind of things. So slowly you can learn actually. Basically you have to do the small experiments and do that. And also you can go through the lot of literature is available. Keep understanding. I think, but actually now you are in the early stage. Now at least you require at least 4 to 5 years of the study in that particular line. Then you can become the very good designer in the whatever you required in the satellite technology.
Thank you, sir.
Thank you. Last question from V. Rohit.
What is the radiation emitted by the Chandrayaan-3 mission, Vikram lander and Pragyan rover to the Earth in a lot of 1,000 kilometers of distance? Is it high or very low? How can we prevent it for our future generations?
Great thinking process. See, finally, electronics which we make to carry out some functions, they will also have some radiations in the form of RF radiations, its own. And any interaction between these two is the one which is going to come in the way of carrying out our functions. So that way, whatever we have made systems to realize the rover or lander or the other propulsion module, which is nothing but orbiter, to see that internal to each of these elements, each of this rover and lander, a system emitting radiation, subsystem within that, is not going to affect the other systems. So it is usually called by a simple term, electromagnetic compatibility. So tests are carried out for that compatibility, and also electromagnetic radiations in the form of conductive radiations or radiative emissions. So those are also what will impact the neighboring systems this all characterized as part of design evaluation. So that way they have not interfered with each other within each of these elements. And then whatever came out of it, RF power as it goes through space, it will get attenuated fast enough, and then it is not going to reach. And as you told, within the 1,000-kilometer range from where we have left that, currently they are dead, it is not emitting anything first of all. When it was alive also, whatever emitted, it is not powerful enough to reach anybody who is there at 1,000-kilometer orbit, maybe some other satellite which is launched by some other space if it is available also. They also go through their own conducted susceptibility emissions, radiations, this compatibility tests. But then usually what comes from distance will be attenuated, and it is designed to overcome, if at all, any radiations in a particular band by avoiding functions being carried out with some clocks and then frequencies of circuit operations in each of those things to really not get affected. So that way there is no fear of anything we have launched, even when it is alive, it is not going to cause levels of radiation which can affect another satellite, or assume that tomorrow some person is going to stand there, and then whoever has to stand in that environment at that 1,000-kilometer from where moon has landed, he has to be actually in some enclosure which should have its own environmental control and life support systems. So that way there is no fear. Your imagination is good. Keep thinking whatever wild ideas comes to your mind. That is maybe first step towards understanding lot of doubts, and then unlearn lot of things, and then keep learning what is required for you to really contribute to the space technology area.
Thank you, sir.
Yeah, your point is very good. See, we are in the earth. We are not thinking about the radiation problem from the cosmic rays or any sun and all. Why? The basic reason is we are having the atmosphere. That atmosphere is shielding us basically. Yes. The cosmic rays entering into the sun is a shielding actually. So, but when you go behind that, we have to face that. So what we have to do? We have to shield it. How to shield? Even electronics components will not work on that radiations. Cosmic radiations, high radiations and all, even the magnetic waves and all that. That is the reason what we are studying now, that Aditya L1. In that what we basically are studying, how that whatever the CME is that actually that corona mass ejection. The sun ejects that corona mass is actually the energy, high energy particle it emits, and also it emits that magnetic field. So continuously that radiations are going out. That is what the basically that the sun is. It is going to emit continuously actually. So this cosmic rays, that means that to detect these things, what we are using, high energy, low energy, X-ray particle, X-rays we are using, and they detecting that intensity of that radiations. Why we are doing that study? To protect all our satellites. So because suppose if you know that one, what kind of intensity of these radiations coming from the cosmic, and also that tomorrow we are going to in the space station and all, if you are staying there also we will get affected by that cosmic rays and all, and also that radiations. So we should be develop such a system that to counter that one actually. In the Earth atmosphere we are not facing because of the atmosphere. There we have to counter that one. So that is lot of research is involved in that also now, that how to, suppose in case if it is the radiations or levels are high, further high it goes on over the years, how to protect the people in the space station and all. A lot of expertise. But the idea is good actually, that actually there is a problem actually. That problem solution you can also think over that one, and how the mitigation technique also you can go through the literatures.
Insightful interaction with the students. Brilliant question, students. Big round of applause to all the students. Students, pat yourself.